Okay, so we are up to section 6.4a in our notes. We're going to do a 6.4b in class. We're going to investigate a couple more ways to prove triangles are similar. Up to this point, the main thing we've discussed, and I don't want you to write that yet, the main kind of easiest way to prove triangles are similar is to look for congruent angles. So if I were to make these two triangles similar, there's our symbol for similarity. We would look for a pair of corresponding angles to be congruent. And if we could prove that, then we would know for a fact that the triangles would have to be similar. All right, zoom in a little bit for you. Okay, once the triangles are similar, then we know that all the sides must be proportional. And that's when we can start looking at our scale factors. That's when we can start looking at our proportions to solve for missing sides. So we can use that knowledge to actually find a couple other shortcuts to prove triangles are similar. It doesn't always have to be angles that are congruent. Okay, so let me just kind of say that one more time. To prove triangles are similar, we always need to look for congruent angles. And once we know the angles are congruent, that means the triangles have to be similar, and it means the sides have to be proportional, and there has to be a scale factor. But there's a couple of shortcuts that we can do to also prove similarity. All right, so there's actually three methods to prove triangle similarity. And those three methods involve looking for congruent angles or proportional sides. All right, so we can look for either congruent angles or proportional sides. So there's going to be three methods to memorize. Just like with triangle similarity, it's really important not to get these mixed up. So I don't even want you to write this, but remember we had our SSS, our ASA, our AAS, all those 5 reasons. We have 3 that prove similarity. Okay, and the first one is the one we've done a lot of. The first one is angle-angle. All right, so if two triangles have corresponding angles that are congruent, it means they must be similar. So as always, if I'm going too quick, please pause, rewind, take advantage of the video. So two triangles are similar if two pairs of corresponding angles are congruent. This is the one we're used to. So angle-angle. Moving on. Pause if you need to. We also have SAS, similarity. So the next way to prove similarity, let's say we don't have angle-angle. We also know two triangles are similar if one pair of corresponding angles are congruent and the sides adjacent to that angle are proportional. So we'll look at what that means in a second. So if we only have one pair of angles, we can still prove similarity, but the sides next to that angle have to be proportional. There has to be a scale factor. So adjacent, we know, means next to. All right, pause if you need to. I'm going to move on. We also have SSS. And again, notice this is not congruency. This is SSS for similarity. We can also prove triangles are similar if all 3 corresponding sides are proportional. So it's kind of like working backwards. Instead of looking for the angles and then showing the proportions, we can just look for the proportions, and if they're all the same, if those scale factors are all the same, then it means automatically the triangles are similar. All right, so I'm going to move ahead. If you need more time to rewind or go back to look at those notes, you can. But let's look at a couple of these together. So number 1, the key here is they're asking us if these triangles are similar. Is ABC similar to DEC? We don't know it right off the bat. We can't just assume that they are. because we don't have enough information. We don't know angle, angle, right? So we don't have angle, angle in this case. That's always our kind of our first option. That's the one I would always look for first. But in this case, we don't have angle, angle. We do have some side lengths, though. So here's what we're going to do. We have to decide, is this an AA? Can we do SAS with this? Or can we do SSS for similarity? So I think hopefully at this point we all see we have these vertical angles, right? It's not reflexive, it's vertical. So we do have vertical angles here. So we have a possibility for this to be an SAS similarity question. So what we have to do now is test to see if the sides are proportional. So we've done a lot of these types of questions. What I always suggest is that we redraw the triangles. So if I kind of look at this small triangle, we can see that there has to be a rotation that happens here to get the sides to correspond, right? To get those sides to match up. So if I redraw my small triangle right here to make it look like the big one, I have my angle. I know this is C. After the rotation, this becomes D, and that side is E. So the sides I can label, I know this is 5, and after the rotation, this is 3. So we have that SAS relationship. So now all we need to do is to ensure that the sides are actually in that same scale factor. So if I look at the relationship of 20 to 5, 20 over 5 would be the scale factor here to here. I need to make sure that scale factor matches up with the 12 over 3. 20 over 5 is the same as 12 over 3. That's the scale factor. And absolutely, when I divide those out, we get 4 on both sides. 4 equals 4. So that tells me that the sides are proportional. So I can say yes. The triangles are similar because of the SAS similarity criteria. So that's an example of how the SAS would be used. We have to show that those triangles have proportional sides. All right. I want you to try to set up number 2 on your own. So notice already they're not lined up the same way. So the first thing I want you to do is to redraw the triangles so that you can really tell which sides correspond, if you think that will help you. And then I want you to test which of those 3 methods you think you will use and actually test it out as well. So I'm going to pause to let you do that, and then I'll show you my work when we unpause it. So go ahead and try this one out now. So the first thing that might help is to visualize those triangles so that they line up. So you can see what I did there is I kind of rotated my bigger triangle to get the sides to correspond. And that's what we did in class with the right triangle Statue of Liberty question. All right, we wanted to make sure we drew the triangles out so that they lined up. So now that we have those proportional, or those sides all lined up with each other, this looks like a potential SSS similarity. It's not AA. We don't know any angles. So again, what we're going to do is test out the 3 proportions. So I'm going to say, is 7.28 over 5.46 the same scale factor as 3.6 over 2.7? Is that the same scale factor as 10 over 7.5? And when we test those out in our calculator, they actually all come out to be 4 over 3. So there's our scale factor. They all come out to be the same. All right, so again, this works. So I can say yes because of SSS similarity criteria. So it works. All right, so it's a lot like what we've been doing. But instead of me telling you the triangles are similar, we have to prove it on our own. All right, so why don't you guys take one more minute. I think the last one looks familiar. Try that one out, and then when you unpause it, I'll have my answers there, and then we'll talk about what's next. Pause now. So I know I didn't tell you this time, but hopefully you took advantage and you redrew your triangles. It's always going to be helpful. This is a very common type of similarity question. This actually is like our snow cone question upside down. We've seen a lot of dilations look like this. So the dilation would be centered at A. And here's another good opportunity. If I were to ask you for the scale factor here, we don't know the lengths of the sides. But if these triangles were similar, remember how we did this in class? We looked at naming the scale factor just with the sides themselves. So the scale factor, if I was to look to go from the small triangle to the big one of the scale factors I could use would be BC over DE, right? I could just name those sides. But the reason these are similar is we have a reflexive angle. Angle A is the same angle in both triangles, so I can say yes, they are similar because of, this is our good old angle. So those are your three rules, your three ways to prove similarity. We're going to have a 7-point quiz next class. I have a couple questions on the Google form for you to try out. Remember, if you get them wrong, I will allow you to resubmit them until you get it right so you can figure out what your mistakes are. So do your best with those. Come see me if you have any questions. And good job, guys. I'll see you next time. Bye.